So good day, lovers of STEM, and welcome back. Today we're going to talk about Kirchhoff's current law. Kirchhoff's current law states that the sum of the currents into and out of a node equals zero. Recall that a node is the meeting point of circuit elements, and today we will show that when you have elements in series across a node pair, that the current into and out of either the top or bottom node will sum to zero. Come along and let's take a look at an example. Okay, so here we are going to make a circuit where all of our elements are in parallel. So we're going to have a current source in parallel with three circuit elements that I'm going to show as a box. These boxes could represent another current source, a voltage source, a resistor, an inductor, or a capacitor. So now, if I make my current source 20 amps, I'm going to draw currents going into the node and out of the node. And what I need to show here is that it sums to zero. So let's say this first element has a current of 5 amps, and this second element has a current of 10 amps. So I have 20 amps into this top node, and then I have 10 amps into this top node, but I have 5 amps out. So that means this node here has to be 25 amps. And recall, all these elements are in parallel, so they have the same voltage. So current into the top node is 20 plus 10, and current out of the top node is 5 plus 25. So that means current in equals current out, or that the sum of the currents into and out of the node is equal to zero. So another way of stating that would be negative 20 minus 10 plus 5 plus 25 equals 0. So good day, lovers of STEM, and welcome back. Today we're going to learn about Kirchhoff's voltage law. Kirchhoff's voltage law states that the sum of the voltages around a loop is equal to zero. A loop of circuit elements, which is exactly two, meet at a node, and they share the same current, and it makes a big circle, thus the name loop. Let's take a look at a couple of examples. Okay, so the first thing we're going to do is we're going to make a loop. So let's say we have a voltage source here, and the voltage source has 10 volts across it. And then we're just going to make these three circuit elements that I am going to represent as boxes. These boxes could be other voltage sources. It could be resistors, inductors, capacitors, or whatever. So this is what we call a loop. And everything in this loop has the same current I because they're all in series, because exactly two elements meet at a node. And when exactly two elements meet at a node, they are said to be in series. There are 1, 2, 3, 4 nodes in this circuit. So Kirchhoff's voltage law that says the sum of the voltages around the loop is equal to zero means that if I have a voltage rise, which means the current goes into the negative terminal and out of the positive, then I have a voltage drop here of 5 volts, a voltage drop here of 3 volts, and a voltage drop here of 2 volts. The sum of the voltages around the loop equals 0 means that 10 equals 5 plus 3 plus 2, which means that voltage rises equal voltage drops. Or another way of stating that is that the sum of the voltages around the loop is equal to 0. So negative 10, a rise, plus 5 plus 3 plus 2 equals 0.